Hi, my name is Heather Hanslick, and I'd like to present the research I've completed on levels of mercury pollution on inland seabirds, specifically female wintering red-legged kittiwakes on St. George Island, Alaska from 2011 through 2017. Is the average mercury concentration in female wintering red-legged kittiwakes greater than 4.5 micrograms per gram of dry weight? You can see that hypothesis written here in symbols. I'm using a data set of mercury concentrations that were collected through winter-grown nape and head feathers from red-legged kittiwakes on St. George Island, Alaska from 2011 through 2017. These concentrations were categorized by mercury concentration in D15N isotope, a bird ID number, their sex, the habitat cluster, location, their arrival and departure dates, the duration of stay, and year the sample was obtained. This data was reported by A.B. Fleischman and J.T. Ackerman in a U.S. Geological Survey data release in 2019. I chose to select female mercury concentrations for all 7 years as my data set. The descriptive statistics. After selecting females only from this data set, I ended up with a sample size of 40. And I could begin to see that the likelihood of mercury concentrations being greater than 4.5 micrograms per gram of dry weight for the selected females by these descriptive statistics. I ended up with a mean value of 4.8243232, a standard deviation of 0.8667051, a standard error mean of 0.137031, a minimum value of 2.893627, a quartile 1 of 4.4319808, a median of 4.8013925, a quartile 3 of 5.447515, and a maximum value of 6.456643. Using the JMP application to calculate a confidence interval for the population mean of mercury content in these wintering female red-legged kittiwakes resulted in a lower limit of 4.547137.5 micrograms per gram of dry weight and an upper limit of 5.101589 micrograms per gram of dry weight. The value of 4.5 micrograms per gram of dry weight or greater is within my confidence interval, inferring that there is a 95% probability that the true value falls within that range. Hypothesis testing. I selected a significance level of 5%, meaning that there is a 5% risk of rejecting the null hypothesis when it is true. And the result shows a test statistic value of 2.3667. This is used to calculate the p-value of the results and shows how closely the observed data match the expected distribution under the null hypothesis of this test. My p-value resulted in a 0.9885, meaning that I should not reject my null hypothesis since it is greater than 0.05. This means that the mercury content in wintering female red-legged kittiwakes from 2011 through 2017 is greater than 4.5 micrograms per gram of dry weight. In conclusion, I have concluded that wintering female red-legged kittiwakes had a greater amount of mercury than 4.5 micrograms per gram of dry weight, and mercury poisoning in birds can result in changes of gene expression, interruptions in reproduction, and cause eggs to become smaller. Studying these levels and where they come from help us understand what is happening in the surrounding environment, and these birds served as bioindicators for St. George Island, Alaska from 2011 through 2017. And here are my references, and thank you so much for your time.